Welcome. So after discussing data models and the data workflows, we are now talking about data processing. So we have started looking at Spark, which is one of the data processing engine, and it's a unified data processing engine. So we got introduced to Spark last week. In this week, we are going to get introduced to a specific library in Spark called the Spark SQL. And then we are going to see why was the importance of this library, because in the early days of Spark it didn't come with the Spark SQL. So why SQL with Spark? And then we are going to see what are the features of Spark SQL, like some features like Schema-on-Read, what are the advantages of it, and what are the multiple ways in which we as developers can use Spark SQL for our big data processing needs. So let's get started. Let's recap what Apache Spark is all about from last week. So Apache Spark, as we have seen, it's a unified open source parallel or distributed data processing engine for very large scale data analytics, right? So the Spark ecosystem contains Spark core at its middle, and there are the Spark core is the general execution engine, and it has 4 libraries. In some cases it's called modules or services, depending on who you're talking to, right? You can think of it as libraries which gets added on to your Python module, but each of these modules are very, very distinctive, built for certain specific use case. In this, so there are 4 such modules, which is the Spark SQL, Spark machine learning library, MLlib, then Spark GraphX, which is for graph data, and then Spark streaming. In this module, we are going to take a deeper look into Spark SQL. So let's get introduced to Spark SQL module. So structured query language or SQL it's been there for very, very long time. So the whole idea is in the initial Spark core, it didn't support SQL, because SQL is something that's prevalent and a lot of developers tend to use it, right? So the use of structured query language inside Spark is what this module supports, Spark SQL. So query structured data inside Spark programs using SQL or similar DataFrame API. We'll talk about DataFrame in detail later. So one of the greatest advantages of this Spark SQL module is it's a backbone for data engineering on Spark. So as we see, most of our big data queries is querying or joining multiple tables, and Spark is a data engine focused on large scale data analytics, right? So these queries form the backbone of data engineering. In the initial version, which is the core engine, SQL was not supported, but it was just a very intuitive choice to actually get SQL included into Spark for processing especially structured data. So another reason why Spark SQL module became popular, or a very intuitive way to expand on the basic Spark core engine, is a consistent way to connect to a data source, right? Because once you have a data source, be it your data table, any structured data source, so their structured data source can come in terms of connecting to a SQL database, or it can come in the form of a CSV file, or it can come in the form of semi-structured data like your JSON file, or even data which is probably stored in Hive format, right? Or Parquet, which is another structured data format. So SQL sort of helps to give a common way to connect to any data source, right? Any structured data source, because structured data source can come in multiple ways in the same way. The other advantage, of course, is integrates with other Spark services. So as we go along, we'll see how it can help. Once you have Spark SQL, then you can build advanced analytics by using your Spark ML library, etc. So why SQL on Spark? It is very intuitive because SQL is a language that existed much before Spark came in, and it was more prevalent, right? SQL is very expressive and it's a readable query language. So people are familiar with it. It supports complex queries. You can do joins on multiple tables, and then you have a lot of aggregation functions. So there are inherent advantages of SQL. So a lot of data processing can be the initial step of data processing. Some of the transformations, etc., can be done as part of your SQL queries itself. So hence the need for SQL on Spark. So again, SQL supports performance tuning and optimization. So there is already a lot of optimization in terms of how to write queries. Spark SQL engine will take the SQL written. So we'll talk more about how the whole process unfolds. Right? We'll take the SQL written and create a logical and a physical plan. Instead of manipulating the resilient distributed data set in Spark core, right? So how Spark SQL looks at tackling complex query with against how does it happen in RDD. We will talk a little bit in the subsequent video, but this is what happens. So it's a sort of Spark SQL engine is a natural extension to Spark because being a big data processing engine, SQL supporting SQL language was a very intuitive module on Spark. So it can be used from other Spark languages as well. So as we have seen, Spark is natively written in Scala, but Spark also supports Python and R. So Spark SQL can be used from other Spark languages as well. So let's talk a little bit about some of the features of Spark SQL. One of the very important feature is Schema-on-Read. So Spark SQL shouldn't be thought of as a relational database. So Spark SQL is not a database. So data is not stored in the RDBMS. So data can be stored in any of the big data platforms like your Databricks file store, DBFS that we have seen, or Hive, etc. Right? But the interesting thing is external data can be described structurally. So you can have a CSV file which is staying on Databricks file system, or for example a Hive storage. So let's say you have an employee CSV file, so you can get it read into your Spark ecosystem by describing the schema. So once the schema is described, then you can pretty much treat it as a table. Right? So you can then do querying on it instead of doing manipulation like how we used to do with your pandas data frame, right? You can just say, in this case, so if you have an employee CSV file which has 4 columns, first name, last name, hire date, and department. So if we mention the schema while reading the CSV file, then you can do this amazing thing of querying the the file itself. So the data doesn't get changed into a relational database or anything, but it's just that you are able to use some of the RDBMS tool, which is your SQL, which is a very familiar thing for developers, right? The way we look at accessing data, we can use that to query any external data, any file which is structural, right? You don't necessarily have to have a database to ingest your data. You can directly use just your CSV, load it into Spark and start querying. So the schema information itself in Spark is stored in what is called a meta store, right? So it can be directly queried from file storage. That's what I meant. So when you have an RDBMS, so you typically have to get a CSV, load it into an RDBMS like Postgres or a SQL server. But the whole idea of Spark is if you have a CSV file which is probably 1 or 2 gigs, it has quite a lot of data. So you can directly sort of query your SQL once because of this module, your Spark on SQL. So some other features of Spark SQL is it supports the standard select syntax that every developer is aware of, right? So here if you look at the image on the right, it shows how your Spark SQL sort of sits on top of your Spark core. So this has access from Scala shell, Python shell or R shell, irrespective of which Spark language you are doing. So when you are reading this file, then it starts creating this SQL meta store where all the schema information is done, so that you can write your SQL queries directly in your Databricks notebook, right? And access the data that is there in your CSV file. In doing this, it does not have to have any database catalog. So that is the key difference that one needs to understand. Spark SQL is not a data store. So it is not a RDBMS. So when you look at RDBMS files, right? So RDBMS has a lot of these maintenance or administration tables called information schema table, etc., which takes care of how many tables are there, what are the columns in the tables, etc., in a Postgres database or a SQL Server database. So Spark doesn't take care of any of this. All that it cares about is where is the location of the file, what is the schema of the file, right? So of course, Spark SQL is built on top of the data processing engine. So it does not support any stored procedures or functions which are there in your RDBMS. So this is sort of comparing Spark SQL with your RDBMS. You can't do any stored procedures or function, but of course you can do what is called a user defined function. We'll talk about that a little later. Because you are directly reading from the file and querying the file, it does not support any referential integrity, right? So you have to load each of your file independently into a table, and then you can write joins. It's not that you cannot write joins, but it doesn't support inferential integrity. So what that means is, so if you remember when we talked about normalization, so in order for your data integrity to be maintained, so for a certain row to be there in a certain table, the corresponding foreign keys should have been there in the corresponding category ID, etc., which you are going to use should have already been there, right? Else SQL or RDBMS system, your database will not allow you to enter, because there is a foreign key relationship. Only if category ID is there in the category table, then you can put a product with that category, for example, right? Spark SQL does not talk about all of that, because all that you are caring about is accessing the data which is there in your CSV. You can load as many files as tables and start querying. You can join these tables as well, but there is no referential integrity in terms of, hey, how come there is a category ID which doesn't have an equivalent reference, right? So because each of it has come as separate CSV files. Of course, there is limited security support in terms of Spark SQL compared to your relational database. Now that we have got introduced to Spark SQL, there are multiple ways to use Spark SQL. So we are going to look at each of them in this module. So first is directly using the SQL data definition language statements, such as creating a table, updating a table, dropping a table, creating tables, views, creating, dropping and changing partitions, etc. So how do we directly use what that is called a data definition language, DDL, on the Spark platform? So the next way is we are going to see how to use Spark SQL using Python, right? So which is the Python shell on Spark, PySpark. So SQL statements in Python. Then we are going to get introduced to the data frames concept in Python, because we have just been talking in the last week about the resilient distributed data set. So there is a lot of work that is needed for RDD. So later Spark came up with the concept of data frames for your structured data, right? So we are going to see how to use that. And finally, just like any other way, considering this is a big data platform, of course, we are assuming your data will come in files, or it's staying in your distributed data store. But there is a possibility of having it in a relational database also. So we can see how Spark can be used to connect to a SQL database and load as a data frame, so that you can do further analysis, filtering, any transformation on it, right? So these are the three ways we are going to look at in this module. So let's summarize what we have learned in this module. So we got introduced to Spark SQL, which is one of the 4 main libraries that sits on top of the Spark core engine. We also talked about why SQL on Spark, right? Some of the features of Spark SQL. It is very important to know Spark SQL does not mean Spark is a relational database, but we are actually using the structured query language in the data processing sense, right? How are we bringing that tool into big data processing, and how it helps in doing transformation and optimization of your big data. And we finally looked at what are the multiple ways to use Spark SQL. So in this module, I have given reference to the GitHub and the YouTube playlist of Brian Cafferkey. So I have used a lot of materials from him and used that as a motivation for building this week. Heavy thanks to him. So please do check it out. Because of the constraints of time, we will not be going at that depth of what he goes to in his tutorial, but I have used some of his material for our work. Thank you.